All right, today we're going to look at secant and cosecant. We'll start out with cosecant. Cosecant is the reciprocal of what trig function? Sine. Cosecant of x is 1 over sine of x. So, let's look at some values. At 0, the sine is 0. What's the reciprocal of 0? What's the reciprocal of 0? Well, 0 is 0 over 1, right? What's the reciprocal of that? 1 over 0. What's 1 over 0? Undefined. Okay, that's undefined. So let's look at the next spot. Let's go to pi over 6. What's the sign at pi over 6? One half, correct? Might need a unit circle to help you out. What's the reciprocal of 1/2? 2. Let's go all the way to pi over 2 now. What's the sign of pi over 2? 1. What's the reciprocal of 1? 1. The reciprocal of 1 is 1. 1 over 1 is 1 over 1. What about 7 pi over 6? What's the sign of 7 pi over 6? Positive. Oh, no. I want to go 5 pi over 6. That's 7 pi over 6. So the sign there is 1. The reciprocal of 1 is 1. How about at pi? What's the sign of pi? The sign of pi. 0. What's the reciprocal of 0? Undefined. And then 7 pi over 6 is negative 1/2, somebody said. So what's the reciprocal of negative 1/2? 3 pi over 2. What's the sign of 3 pi over 2? Negative 1. What's the reciprocal of negative 1? Negative 1. 11 pi over 6. What's the sign of 11 pi over 6? Negative 1/2. What's the reciprocal of negative 1/2? Negative 2. Hopefully this is enough information to help us graph this. Okay, so what I'm going to do is I'm going to graph my sine curve. So I'm going to graph y equals sine of x, 0, 1, 0, negative 1, 0. At pi over 6, I'm at 1/2. So I'm putting my places where I'm 1/2 at. And then if I graph my y equals cosecant of x graph, at pi over 2, I'm at 1. Same place where sine is at. Okay, that's where they meet. So I'm at 2 at pi over 6, and at 2 at 5 pi over 6. I'm at negative 2 at 7 pi over 6, and negative 2 at 11 pi over 6. Negative 1 there. And then at pi, I'm nothing. If you can't graph there, you have an asymptote. So we have an asymptote there, an asymptote there, an asymptote there. So what do your graphs look like? Well, they kind of look like parabolas. They go until there, up, go until there, down. Now, do not just go like this, because that's wrong. A V is wrong. They're a parabola-shaped graph that goes towards the asymptotes, but do not cross your asymptotes. Okay? So that's what y equals cosecant of x looks like. Now we're going to go y equals secant of x, which comes off the y equals cosine of x graph. So we'll graph cosine of x. I'm not going to go through all the points like we did last time. So we got pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 1, 2, negative 1, negative 2. Okay, where does cosine of x start? At 1. So we start right there. And then we're at 0, then we're at negative 1, then we're at 0, then we're at 1. Then I'm going to keep going. And you'll see why in a little bit. That's a cosine curve. So the secant of x. Now, where it's 1, it'll be 1. Where it's 1/2, it'll be 2. Where it's negative 1, it'll be negative 1. Where it's negative 1/2, it'll be negative 2. What happens where it's at 0? When the cosine is 0, what happens to the secant? What's special about that? What do we know about the secant right there? It's what? Undefined. Because the reciprocal of 0 is 1 over 0, which is undefined. We cannot divide by 0. So we're going to have an asymptote there, an asymptote there, and an asymptote here. Okay, so they look kind of like that. So don't graph of a half of a parabola. So for cosines, you're going to have to work over a little bit. Okay. All right. So that's fairly easy. Graph of parabolas from the cosine curve or from the sine curve. Now, where it gets a little more complicated is when I have something like this. Y equals 2 secant of x minus 1. So how am I going to graph y equals 2 secant of x minus 1? Well, I'm going to graph y equals cosine of x. I'm going to graph y, then I'm going to graph y equals 2 cosine of x. Then I'm going to graph, let's do hot pink, y equals 2 cosine of x minus 1. Then I'm going to graph the secant one. So I'm going to graph all my cosines first, and then I'll graph my secant. All right, so pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 1, 2, negative 1, negative 2, negative 3. All right, so cosine of x curve starts at 1, goes to 0, goes to negative 1, goes here, goes here, goes here. What does 2 cosine of x look like? What does that 2 in front do to the cosine curve? Twice as high, twice as low. Stretches affects the amplitude. Okay. Now what? What does the minus 1 do? Is that a stretch or shrink, or is that a translation? Translation. Translation where? Down 1. So translation down 1. So I'm there, I'm there, I'm there, I'm there, I'm there, and I'm there. All right, here's where you have to be really, really careful. Okay, where are my asymptotes going to be? Exactly, Cheyenne. They're not going to be where this last graph crossed the x-axis. Okay, they're going to be where we normally cross the x-axis. That's where my asymptotes will be. So my asymptotes, I'll do in light blue, will be here, here, and here. What this minus 1 does is just takes my normal graph and shifts it down by 1. It doesn't change the plate where the asymptotes are. So my final graph will look like this. It'll look like this, a parabola down here, and from here, a parabola up here. Okay? So we stretched it, and we translated it, and that's how it looks. Okay? After a stretch and translation. Okay, let's do another one. Let's go y equals negative cosecant of 2x. Y equals negative cosecant of 2x. Let's figure out what we got going on there. Okay, so what I'll graph first is y equals sine of x. Then I'll graph y equals negative sine of x. Then I'll graph y equals negative sine of 2x. Actually, I did this wrong because 3 isn't divisible by 2 very well. So I better go 4 spaces. Pi over 2, pi, 3 pi over 2, 2 pi. All right. So sine of x. Sine of x starts at 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. Looks like that. What does negative sine of x look like? What do we do to get negative sine of x? Flip it. So that doesn't move. That goes to negative 1, doesn't move. There we are. What's negative sine of 2x? What does the 2 do to it? Shrinks it how? Horizontally or vertically? Horizontally. It affects the period. It's twice as skinny. I wish I could be twice as skinny. But we're 0 here. Here. Half of this is here. Half of this is here. Half of this is here. Okay, that's twice as skinny. Now we put it in the asymptotes. Okay, where do the asymptotes go? Well, they go where we're at 0 in this case. Okay, it's only when you shift up or down you don't go where there's 0. Okay, besides that, for secants and cosecants, where your equal is 0 is where your asymptotes are. Because the period shrinks everything down twice as much. So your final graph looks like this and like this. Are we good there? We're going to do one more. One more. We're going to do y equals 2 cosecant of x minus pi over 3. All right, since it's cosecant, what are we going to graph? Y equals sine of x. Then I'm going to graph y equals 2 sine of x. Then I'm going to graph y equals 2 sine of x minus pi over 3. Once I get those done, then I'll put in asymptotes and figure it out. All right, so I got a pi over 3 involved, and I got a 2 involved, but the 2 involves vertical, so the pi over 3 is the only thing I'm worried about. Pi over 3 is a third of the way to pi, so my pi has to either be at 3 or 6 or 12 or something like that. So I'll go 3 to get to pi over 2 and 6 to get to pi. Then I got a pi over 3 is 2 squares. All right, so y equals sine of x. 0, 1, 0, negative 1, 0. 2 sine of x is twice as high and twice as low. Two sine of x minus pi over 3 means we move pi over 3 which direction? to the right, pi over 3. Pi over 3, I said, was 2 squares. Because if it's 6 squares to get to pi, 1/3 of 6 is 2. So 2 squares to the right, 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 2 squares to the right. And asymptote time. So I should have an asymptote right here, and right here. My asymptotes move left and right with doing graphs. So then, it's a parabola here, and a parabola down here. We good? Okay, so we're going to have 6 problems over this for today. On page 135, we are going to do numbers 31, 35, and 41. And then we're going to do 43. We're going to do 47. Oh, 45 and 47. Sorry. 45 and 47. 6 problems. Those will take you a little bit to do. And then that'll be it for today. Then I won't see you for a week because we don't have this class again till next Wednesday.